Hello there, 7th grade. Mr. Hale with you again. The other day we talked about simple independent probability. Simple meaning one thing was happening. We were flipping a coin one time, or rolling a die one time, or pulling one colored marble out of a cup. Today we're going to talk about complex probability, also known as compound probability. And that's where more than one thing happens. We're still going to be doing independent probability. Independent means anything that's happened before does not in any way change the math of what's happening now. If I flip a coin and then flip a coin again, the result of that second flip is in no way changed by what happened on the first flip. They are independent of each other. Let's move to our first example, and that is flipping two coins. All right, thinking back to before. What is the probability of flipping heads on a coin? We're going to flip our coin twice. Our first flip, we want to get heads. Well, on that flip, there are two possible results, heads or tails. How many of them give us what we want? Heads. Well, only one is heads. So our probability of flipping heads on the first coin is 1 out of 2. One result gives us what we want out of 2 total possibilities. Then we're going to take that same coin. We're going to flip it a second time. This time, we want tails. Still the same coin, so we still have 2 possible results. We win if we get tails this time. There's only one way that can happen, so our probability of flipping tails on the second toss is also 1 out of 2. So, what is the probability of flipping heads and then tails? Notice how this is written. P for probability, and then inside the parentheses, the first thing we want to happen, heads, followed by an arrow. I like using these arrows. Some other textbooks and websites use different symbols. Then the second thing we want to happen, tails. Heads and then tails. Let's write down the first probability. First probability was 1 over 2. Don't know why it did that, but no worries. Then we write down the second probability, which was also 1 out of 2. Once we have all the probabilities written down, we're going to multiply them together. 1 times 1 across the top is 1. 2 times 2 across the bottom is 4. So the probability of flipping heads and then tails is 1 out of 4. We write this as heads and then tails as if we're flipping one coin and then another, and that is accurate. It would be 1 out of 4. The math would work exactly the same way if you had 2 coins and you flipped them simultaneously and you wanted to get 1 heads and 1 tails. It's the exact same situation mathematically. Now there's another way that you can do this besides multiplying fractions, but it only works if you have some pretty low-key situations, like where there's only 2 possible results, heads or tails, and that's to make a list. So let's list all the ways that 2 coins could be flipped. You could have 1 coin come down heads, and then the second coin come down heads. You could have the first coin come down heads and the second coin come down tails. You could have the first coin come down tails and then the other coin come down tails. Or you could have a tails followed by a heads. So notice there are 4 possible results of flipping 2 coins. 1, 2, 3, 4. That matches our denominator. And only one of them gives us what we want, a heads and a tails. That's this guy. So 1 out of 4. and that matches up with our fraction multiplication. Let's think about a 20-sided die, a die that has 20 sides numbered 1 through 20. Let's pick two numbers from 1 through 20. Let's say that we're going to do 7 and 1. We want to roll a 7, then pick the die up again, roll it a second time, and roll a 1. Or we can think about it as two 20-sided dice. We roll both of them, and we want one to come up a 7 and the other to come up a 1. Those are the exact same thing mathematically. You have two rolls. One of them is a 7, the other one is a 1. Well, how many possible outcomes are there on a 20-sided die? There are 20, because we have the numbers 1 through 20. How many are the first chosen number? We chose 7. There's only one 7 on the die, so that's one winner out of 20 possibilities. What about the second choice? Well, there's only one 1 on the die out of 20 possibilities, so that's also 1 out of 20. So the probability of rolling them back to back is going to be this probability multiplied by this probability. We're going to do 1 out of 20 multiplied by the second thing we want to happen, 1 out of 20. 1 times 1 across the top is 1. 20 times 20 across the bottom is 400. So the probability of rolling 7 followed by a 1 on a 20-sided die rolled twice is not very likely. 1 out of 400. Okay. Now, typically, I'm not going to write out the problems in sentences like this. I'm going to put them into this format. Remember, the P stands for probability, so our answer is going to be a fraction. We're going to put the first thing that we want to happen first. So the first thing we want to happen is to roll a 7. So I'm going to roll a 7. We have our arrow, which means and then. And then we put our second thing that we want to happen. The second thing we want to happen is to roll a 1. So the probability of rolling a 7 and then a 1. We know from above that that is 1 out of 400. 1/20th times 1/20th. Our second lesson of this unit was on odds. We can turn this into odds based on this fraction. So we're going to write it similarly. We're going to have an O in front for odds, and that means our answer is going to be a ratio, losers on the left, winners on the right. Other than that, we're going to write it the same. We're going to have the first thing we want to happen, a 7, arrow for and then, a 1, the second thing we want to happen. So let's think about what odds mean. We have to have our losers on the left and our winners on the right. So let's look at our probability fraction. How many ways to win do we have? We have one way to win. There are 400 possible results. Only one of them is a winner. So how many losers are there? 400 minus 1, it's going to be a little hard to write, is 399. So the odds of rolling a 7 followed by a 1 are 399 to 1. And now for Mr. Hale's favorite probability demonstration tool, a cup of colored cubes, or a cup of colored marbles. This is the same cup of colored objects that we've had the previous two lessons. 15 total objects, 5 black, 3 red, 3 blue, 2 white, 1 green, 1 yellow. Let's talk about the probability of doing a red and then a blue. So what we're going to do, we're going to take our cup, we're going to shake it up, reach in, pull out a red. We're going to put that red marble back in the cup, shake it again, reach in, pull out a blue. What's the probability of that happening? Well, we know that there are 15 total marbles, and 3 of them are red. We know that there are 15 total marbles, and 3 of them are blue. So we have our two fractions, multiply them together. 3 times 3 across the top is 9. 15 times 15 across the bottom is 225. Now, both 9 and 225 can be simplified. They're both divisible by 9. We could also do our simplification back here before we multiply, because 3/15 can be simplified. 3 and 15 are both divisible by 3. 3 divided by 3 is 1, and 15 divided by 3 is 5. Same thing over here, 1/5. Multiply those together. 1 times 1 across the top is 1. 5 times 5 across the bottom is 25. So that's our simplified answer. And this is the same thing that you would get if you simplified from this fraction. 9 divided by 9 is 1. 225 divided by 9 is 25. The probability of pulling out a red, putting that back in the cup, shaking it, pulling out a blue is 1 out of 25. How do we turn that into odds? Well, there we go. Let's think about this. So we know losers on the left, winners on the right. There are 9 ways to win. 225 possibilities, 9 of them are winners. That means all the rest are losers. 225 minus 9 is 216. This can be simplified because both 9 and 216 can be divided by 9. Or we can just jump to the simplified fraction and do it from there. Remember, losers on the left, winners on the right. There's one way to win. 25 total possibilities. Only one of them is a winner. All the rest must be losers. 25 minus 1 is 24. So the odds of pulling a red, putting that back in the cup, and then pulling a blue is 24 to 1. Oh, I've lost my little tiny cursor. There it is. Let's go back to red ink. All right, what about black followed by green? So black, 15 total possibilities, and 15 total possibilities for green. How many of those are black? 5. How many of those are green? 1. So if we leave it like this, we can do 5/15 times 1/15. 5 times 1 across the top is 5. And 15 times 15 is, again, 225. We could simplify this fraction, or we can do the simplification back here when we multiply. So 1/15 can't be simplified. It has a 1 in the numerator. It's as simple as it can get. So we're going to rewrite that here. And then 5/15, 5 divided by 5 is 1. 15 divided by 5 is 3. 1 times 1 across the top is, of course, 1. And 3 times 15 across the bottom is 45, which is the same as if we had simplified this. 5 divided by 5 is 1. 225 divided by 5 is 45. So the probability of pulling out a black, putting it back in, shaking the cup, pulling out a green is 1 out of 45. How do we turn that into odds? Well, up here with this fraction, we could say we know there are 5 ways to win. We put that on the right. 225, 5 ways to win. All the rest are losers. 225 minus 5 would be 220. We can simplify from there. Both of these can be divided by 5, or we could do it from this simplified fraction. Either way will work. So 1 out of 45, that's one way to win. 45 total possibilities, one way to win. All the rest are losers. 45 minus 1 is 44. The odds of black and then green in this setup are 44 to 1. Now, every example we've done so far has involved two things happening. We can do as many things as we want inside those parentheses. So what if we want three things to happen? We want to pull out a blue, put it back in, shake the cup, pull out a red, put it back in, shake the cup, pull out a yellow. We only win if we get the exact sequence blue, red, yellow. What's the probability of that happening? Oh no, I lost my cursor again. There it is. Go back to red ink. Let's look at blue. Blue is 3 out of 15 from up here. Red is also 3 out of 15. Yellow is 1 out of 15. Now, I can do 3 times 3 times 1 across the top. That's 9. And we could do 15 times 15 times 15. That's about 3,750, somewhere in there. But I'd rather not get into those kind of numbers. So let's skip this step. Let's do our simplification before we multiply. 3 out of 15, we know from up here, is 1 out of 5. This is also 1 out of 5. And this can't be simplified because it has a 1 on the top. It's already as simple as it can get. So now, a little easier to deal with. 1 times 1 times 1 across the top is 1. And then 5 times 5 times 15. Well, 15 times 5 is 75. Times 5. That's going to be 375. I don't know why I put that line there. Don't worry about it. That still should say 375. So the probability of blue, put it back in, shake, red, put it back in, shake, yellow, is 1 out of 375. Let's turn that into odds. What are the odds of that happening? Remember, we got losers on the left and winners on the right. There's one way to win, so 1 on the right. 375 total possibilities, only one of them wins. All the rest are losers. 375 minus 1, 374. So the odds of the sequence blue, then red, then yellow is 374 to 1. As always, do your best on the worksheets that I've given you in that packet. Feel free to email me at my school address if you have any questions. Stay safe, wash your hands, stay home. I hope that I will get to see you soon.